Hey everyone, this is AP, and today I got another Arduino MIDI project, and this one is related to my Specular Tempus delay and reverb. So what I'm going to do with this project is to make a device that can convert an expression pedal signal into a MIDI signal. That will allow us to control the 4 knobs on the Specular Tempus. The reason for this, they have an auxiliary in on this, but it only works for switches. You can do tap tempo or some other functions, but you can't put in an expression pedal through this. But they do allow you to control these knobs through MIDI. Now I was inspired to do this from a video of Pete Thorne demonstrating his pedal board, where he had an expression pedal that was specifically dedicated to controlling the mix knob on his delay. So he could instantly get as much or as little delay as he wanted. And I thought that was really great. What I'm going to do today, I just have the build in prototype form right now. I figured that was better to show since all the components are more spread out and easier to see. So first I'll go through that, and then I'll go through the code on the computer that makes all this run. And then there'll be a follow-up video next week where I actually build this into an expression pedal and show you how it all fits together and show you in action with some music examples. That'll be next week. But all right, here we go. Okay, so here we have a close-up of our circuit. Like I said before, we want to take an expression pedal, which for now I just have this potentiometer, pretty much the same thing. And we want to convert that to a MIDI signal. Here's our MIDI cable that I just soldered some pins into. I'll talk about that more in a second. And then these 4 wires here are going to be 4 switches. And what I envision is that you can flip on a switch and that will correspond to one of the 4 knobs on the front of the Specular Tempus. But yeah, so there's basically 4 parts, or 3 parts. The expression pedal, the 4 switches, and our MIDI circuit. So first of all, I'll talk about the MIDI circuit. That's probably the simplest. The red wire here goes to, if you're looking at the pin here, going counterclockwise, 1, 2, 3, 4, 5. The second pin is 5 volts. And then there's a 220 ohm resistor in series with that, and then it goes to the +5 rail on my breadboard. The next one, the 3rd pin, which is at the bottom, that's just ground, goes to ground. And finally, the 4th pin, going around counterclockwise again, this blue wire, goes over to the TX send. This is the serial send on the Arduino. And that's all you need to make a MIDI connection. I talked about this in my last video. Okay, so now moving on to these buttons here, or switches rather. In my last video, if you remember, I talked about using a pull down resistor. I did a little bit of research and I figured out you don't actually need those. The chip here has built-in pull up resistors. So right now these aren't connected to anything. These are just empty rows. I don't have anything there. So normally that would be kind of an indeterminate state. But since there's a pull-up resistor and that is enabled, these are actually high right now. So all these are enabled. So then to flip the bit or to change the state, all you have to do is connect these to ground, which is this minus rail on this side, just so I don't have to cross wires over to this side. And it's that easy. Literally just one wire with a switch. Or, well, there'd be one coming back to ground. But anyway, you get the idea. And finally, we're going to talk about our little expression pedal potentiometer setup here. So if you've seen a potentiometer, there's 3 lugs on it. The middle lug goes to the wiper, and the outside lugs go to the 2 ends of basically a resistive strip inside of the potentiometer. So what we want to do, we hook one lug, one side of the strip, up to the +5 volt rail, and we hook the other one up to the ground rail. And then this yellow wire here just goes over to one of the analog ins. And I also have a resistor in series with it. It worked without this, but I saw it in some schematics. It's supposed to limit current, which I guess when you're reading in an analog signal, I think this is designed to take as little current as possible, but you might as well have this here for safety. And the way I understand it, the current is so low that you're hardly getting any voltage drop from this anyway. It has no problems going all the way to 0 or 5. So I've moved all of the 4 switches so that they're in the low state. They're connected to ground. And you can see that nothing will happen when I turn the knob. But now, this goes to the first knob on the Specular Tempus. If I disconnect that from ground, now with the internal pull-up resistor, it's high, so it's enabled. And I can turn this, and I can change the level, the wet level, as it's called in this preset. And you can hook up 2 of them. Now this one and the delay time are enabled. Or I guess decay time, since this is a reverb patch. It'll only show one of them because it sends this signal, and then just a millisecond later, it sends the second signal. So then you only see the second one. But it's really just as simple as that. So the idea being, you can just reach down and flip a switch very quickly. Say you wanted to go, usually you'd want to control the mix, but say you wanted to control the speed, or one of these, like this one, this is a reverb with a tremolo on it, and you could control the speed of that with the parameter knob. All you would have to do is flip 2 switches real quick, and suddenly you can control that with your foot switch, or with your expression pedal. Okay. Boy, I was going to use my webcam, but of course, Windows 10 was making that extremely impossible. So now I'm angry. And I'm back to my camera. But, okay, going through the code. First of all, we'll start out here looking at some constants. So any numbers and stuff, I tried to put into variables at the top of the program here. This is before we get into any of the loops or the setup. So if you look here, first of all, I have a debug mode. It allows you to see the messages through the serial logger. And then moving on here, we have our input pins. And it's just digital in, switch 1, switch 1, blend, decay, parameter, intensity. And that's just pins 2 through 5. And then we have our analog in for the expression pedal, that's analog pin 0. And we have some other variables here. So these are the numbers for our control changes for the Specular Tempus. And one thing to note with the new firmware update 3.8, actually none of these are enabled by default. You have to install the SpecLab software, go into the settings menu, and put in a number for each of these parameters. I just went off of what they list in the old instruction manual. I think it's in the new one too. But by default, they're all disabled. Basically, they're 0. So you have to go in and give it your own numbers. So I just gave the same numbers that they had used before. And then I had tested this with my M5. So this is the M5 expression pedal channel is number 1. And then I'll talk about this one here. This is basically the minimum amount of change in the potentiometer that will trigger a MIDI signal. And then finally, we have a delay. So this is as fast as it can send signals. 10 milliseconds apart is as fast as it'll send a MIDI signal. I didn't want to overwhelm the pedal. We have some variables that we read our potentiometer state into. We have the raw value, and then we have the previous raw value that we sent, and then the converted MIDI value, which we'll see in a second. And then the only 3 functions I have defined here are my program change one, which actually I'm not even using. I just left it in there from my previous project, and the MIDI control change function, which is what we'll be using to send our expression pedal signals. It's a control change. I think there are also MIDI libraries that are available that you could use instead of this, but I just found these and it's actually pretty simple, so I'm just using my own code. If you want to do more advanced stuff, I'm sure that you can find something else. Okay, and then this convert raw to MIDI. This function converts the raw value from the potentiometer to a MIDI value, and we'll get to that more specifically. So first of all, in our setup, this is that debug mode that I was talking about. If debug is enabled, we do 96,000 or 9,600 baud rate, but MIDI is 31,250. So that just gets our serial connection going. And then we set up all of our pins. Like I mentioned before, this uses the internal pull-up resistor. So by default, these are in the up or high state. And then if you connect that pin to ground, it will go into the low state. And I demonstrated that already. So now in the loop here, here's our delay first of all. So that's our 10 milliseconds that it's going to wait just so we don't send too many MIDI signals at once. So then we read in our analog position from the potentiometer. It's just an analog read, pin 0, that's the A-in expression pedal. Analog in expression pedal is 0. That's right into this raw value. So now we have this if statement, and it looks at this newly read in position compared to the last position that was sent to the pedal. And if that value is greater than our minimum change that we have set above, which is 8, then we will send a MIDI signal. So the reason I chose 8 is because obviously we have a lot more potential potentiometer values than MIDI values. We have 1023, whereas MIDI we only have 128. So you take 1023 divided by 127, you get about 8. This also filters out noise. The value tends to jump around between +1 -1 from where you have it set when you look at the raw value from the potentiometer. So this kind of kills both of those with one statement. So we read in our value, we compared it to the old one, we found that, oh, we are turning the knob, we have a change that's greater than 8, so now we're going to go in here, and right away we put the current value into the previous value variable, just so that the next time we come around we'll know what we sent last time. And then we take our red value and we go and we convert it to a MIDI value. And as I mentioned before, I'm going to go down to that function, convert raw to MIDI. Basically, I normalize it to 1. So whatever raw value gets read in gets divided by 1023. So that's like a 0 to 1 value. Then I wrote some code to make sure it didn't go lower or higher than 1. Finally, it converts that 0 to 1 value, basically multiplies it by 127. So now you have a 0 to 127 value. And that gets returned back up to the loop. So now we have the actual MIDI value that we're going to be sending. So basically, if we go here, if statement, we have a digital read of the switch 1, which is the blend knob. And if we find that that's high, that means it's enabled. So we're going to send a MIDI control change. This control change number is the one corresponding to blend, which I think was 14 or 15, doesn't really matter. You can look above. And then we're sending it the integer we're sending it the integer MIDI value. There's so many complicated words. And we do that for each knob, and they all get the same MIDI value. I'll go down and look at the MIDI control change function real quick. Basically, there's two inputs. There's the control change number, and then the value that you want that control change to have. So here again, we have this debug that I had written in at the top. So when debug is enabled, we're using serial.print. Basically, it sends it as strings or letters. So if I put in 176, I'll see 176 on the serial logger. If you don't put in 176, it gives you whatever character I think corresponds to 176 in some kind of, I don't know if it's ASCII or something, but it looks like gibberish. It's really unuseful. So if you use print, you get the actual, like visually you get what you're sending. The pedal will no longer understand it unless you go back to, you make the debug false, and then you use serial write. But basically we send a 176, which the pedal will recognize as a control change. We tell it which control change we want to do, and then we tell it the value for that control change. And that's really as simple as it is. So like I said, if it doesn't recognize that you've turned the potentiometer past a value or past that minimum change value, if you haven't turned it far enough, it doesn't do anything. Right here, else, value is not changed. And then this is the end of the loop. So it goes back up. So the idea is you only send a MIDI signal if the pedal changes. I think that pretty much covers it. And I probably talked longer than I wanted to, but hopefully it all made sense. Let me know if you have questions in the comments. Yeah, stay tuned for the video where I actually build this thing. Hopefully it's going to come together real nice. I got some good ideas that I'll talk about, well, when I do it, which I hope would be next week or maybe the week after. Yeah. Thanks for watching this video. Be sure to check out my other videos. And keep on rocking. We'll see ya.